So in this exercise, we'll look at how to create load cases and load items. So if you have not followed the previous exercises, you can now open up my bridge_3.std file and just start working with instructions in this manual on page number 83. Okay. So what I'll do now is go back to the modeling mode. Okay, and this is the bridge that we've created so far. Okay, now we also have the physical beam definition, which is going to help you a lot in order to generate the loadings. Now, the first load case is basically going to be L1 is equals to 8.8 feet, and L2 is going to be located at 1.1 feet. Okay. So when I say L1 and L2, I'm basically referring to the instructions that are given in the AIC Steel Bridge Competition manual. Okay, so for 2011. Now let's create that load case. Okay, on the left hand side, click on General, Load Definitions. Now, just to give you a summary as to what we're trying to do here is if you look at the manual that we have prepared, okay, we show you the load cases that need to be created. Okay, the first load case is L is equals to 0 feet VLT preload. Okay, so basically that just means that we are going to be doing a this is just a preload test load case. Okay, which will include the self-weight of the structure for sure. It has the distributed load. On the left-hand side, we have a load of 0.2 kips. Okay, distributed over a span of 3 feet, and then we have 4 beams to take that loading. So each beam should basically have 0.017 kip foot of loading. Okay, so that's, the calculations are shown here. Okay, please feel free to review those. Then we have all these preload tests cases, and then we have VLT step 1 and step 2 cases. Okay, so here we have gone in and put in basically all the values, possible values of L, and created the loadings. And basically your bridge has to be designed for the worst case scenario, right? So let's look at the first load case here. Okay, so here we have in the manual it says L is equal to 0 feet VLT preload. Okay, so on the right, in your STAAD file, okay, if you go to load and definitions, on the right hand side you'll see load cases details, right? So once you find that, you just click on the Add button. Okay, and you can type in the name of the load case. Okay, so in this case, the name of the load case would be, if you go back to page number say 15 of your manual. Okay, the load case name is L is equals to 0 feet VLT vertical load test, and this is going to be a preload. Okay, and the loading type, we'll just set it to none. Click on Add and hit the Close button. So on the right hand side, if you click look at load cases details, under load cases details we have that load case already created, right? So what we'll do is we'll click on that L is equal to 0 feet VLT preload, click on the Add button. Okay, and it'll pop up this Add New Load Items dialog box. Now, be careful, because what we need to do is we need to assign the loading to the physical members, not the analysis members, okay? So let's go to physical member load. The loading that we need to define is 0. It should be negative 0.017 kip per foot, okay? The D1, which is the distance, is going to be 0, and the ending distance is about 3 feet, okay? So that's from the start node of that physical member. And just click on add. Now, let's close this dialog box, okay? We'll look at how this loading gets applied. Now, on the right-hand side, if you click on uni gy and the new command that has been created, on the left-hand side, you have to click on the physical member cursor, okay? And what we'll do is we'll just draw a window like this for the whole structure, so that'll select all the physical beams in the model. Or you can just say assign to view, okay, and click on assign. So what that'll do is it'll assign the loading, okay, but you have to make sure that the toggle physical mode is also on, okay. So so it says 1 to 4. So members number 1 to 4 has that loading assigned now, okay. So you can go back and review those loadings. Sometimes it has a refresh problem, okay, and we have documented that in the manual also. You might have to close STAAD.Pro, okay. And if you go back to loading, okay, you see that physical member load assigned to the structure, okay. Now, the next thing is creating the next load item, okay. So we have created the load on the left hand side, but there is also, like if you go to the training manual, okay, there is a load on the right side of the beam also, okay, which is 0.0042. Okay, so that loading has to be assigned too. So let's see how we can assign that loading. So on the right hand side, again, what we could do is we can select that same load case that we were working on, okay, which is L is equals to 0 feet. Okay, and what you can do is just click on the add button. Again, the add new load items dialog box will appear, okay. We also need to take the self weight of the members into account. So since we're there, we'll just click on self weight load and click on the add button, okay. And what will happen is it'll add an item for the self weight load in your load case, okay. Now the next thing that we will do is go to the physical member load. Again, uniform force, and we'll just put in negative 0.0042 kip per foot. Again, the calculations for this loading are there in the manual, okay. So we'll just put in 18 to 21, okay. So that loading is going to be we'll start 18 feet from the start node point and end at 21 feet from the start node point, okay. And if we click on the self weight option, click on assign to view, click on assign, click on physical beam, click on assign to view, click on assign, okay. So again, it should show up that loading, but it's just a refreshing issue for now, okay. Okay, now let's create the next load item, which is according to our PDF document page 15 of section number 2. It's called VLT step 1. Okay, so if you click on add, we can type in that load case again. L is equals to 0 feet. VLT step 1, and just click on add, and then we'll add another one later. Okay, so no, we'll just add it now. Okay, we'll just call it L is equals to 0 feet VLT step 2. Okay, so click on add. Now hit the close button. So what we have is 3 load cases created. Let's go to the second load case, click on add, and I'm just going to go a little bit faster now. Click on self-weight load, click on add, click on physical member load, and this time the loading as per that table is negative 0.15 kip per foot, starts at 0, ends at 3 feet. Global Y, click on add, and then we have on the right hand side 0.0042 kips. Okay, starts at what is it, 18, and ends at 21. Click on add. Okay, and click on close. Okay, so now we have 3 load items, right? Just click on assign to view, assign to view, and assign to view. Okay, so that finishes our next load case, and then at the third load case we click on add, and this is step 2. Again, we need the self weight to be considered in that. Physical member load is negative 0.15, starts at 0, ends at 3. Global Y, click on add, and then the load on the right hand side is 0.0058 kip per foot, starts at 18, ends at 21. Click on add, and again assign those loadings to the view. Okay, I went a bit fast for the second and third load case, but basically, you know, all those steps are documented in your manual.